Hi, this is Mike, your professor in ITSC 1309. I want to talk about some Excel Chapter 2 items. The ones that are confusing in this chapter are absolute versus relative cell references, and they also talk about you using the payment function. And then as a bonus, I want to talk about future value. So let me turn off recording my face here and let's get into looking at absolute versus relative cell references. All right, so let's get into understanding the difference between absolute and relative cell references. To do that, I need to get some totals in my spreadsheet here of my cells for Acme Corporation. This is my mythical company. We sell widgets, thingies, whatchamacallits, and thingamabobs. First thing I want to do is get my total for the quarter. Quarter one, I want to total up these four cells right here. I can click right here. And if you remember, we have the auto sum button. So that's going to sum up B5 to B8, and I'm just going to press enter. So I sold 25,000 units because this is cells in thousands. So 15,000, 5,000, 5,000, 0. I can do the same thing here, here, and here. However, I can use my fill handle in the lower right-hand corner of the cell. You see when my pointer changed to a black plus sign, I can drag across and it copied that formula across. So right here, my formula is B5 to B8. I'm going to hit escape. If I double click here, you see it changed it C5 to C8 and so on and so on. It adjusted it for each column it was in when I copied it across. Now to get out of edit mode for this cell, I can just hit escape on the keyboard. And I want to do the same totals for the year right here. Now, if I use the auto sum again, this time it's smart enough to sum it all the way across, and I can press enter, and you can see for the year I sold 54,000 widgets. Isn't that exciting? Now, I can copy this down by using the fill handle, but unfortunately, it's going to copy my formatting. You see how it copied the blue all the way down? So I don't want that. I'm going to hit undo right here. And I'm going to use the fill handle again and drag it all the way down. But this time I'm going to hit the little autofill options and say fill without formatting. So there we are. Now it looks great. Now I can see that for the entire year I sold 230,000 of the different products my company sells. Widgets was 54,000, et cetera, et cetera. Whatchamacallits were my most popular product. And if I double click on this formula right here, you see I'm just totaling up the totals for each of the four quarters. Now, here's where we get into absolute versus relative cell references. I want to get the percentage of the total for each. Let's see if I can get that thing to go away. Nope. Let's do a formula right here. I want to do a percentage of my total cells. So if I say equal, this is the total widget cells divided by the grand total. That's 23% of my cells. Now, I made all of this right here. I made it percent style, okay, already. So if I wanted more detail, I could say increase decimal places, and now I can see it's 23.5%. Isn't that just astounding? Now, here's the problem. If I take this formula, I want to do the same thing for thingies, whatchamacallits, and thingamabobs. But if I take this formula and copy it down, I'm going to get an error. Well, first of all, I copied with formats. Let's fix that. I'm going to copy it down and say fill without formatting. But you see it says divide by 0 right here, right here, and right here. So when it copied the formula, it didn't copy it right. What happened is when it copied this formula down, let's look at the original formula. It was F5, which is my total for widgets divided by the grand total. That's what I wanted. But when it copied it down, when I copied it down one row, it changed the F5 to F6, which is great. That's thingies. But unfortunately, it changed F9 to F10 because everything moved down one row, so it changed the formulas to be one row lower for both of them. And we can see the problem here. It changed the F9 to F11 here, and it changed the F9 to F12 here. Now I could fix that. I could select that and click there and fix it. But I don't want to have to, if this went down 100 rows, I don't want to have to edit every single formula. So let's write the formula. I'm going to click I'm going to double click on here. I can hit F2, function key 2, or I can double click. And the problem is when I copy this formula down, I want F5 to turn into F6. But I don't want F9 to ever change. Now, the way you do that is a couple ways. I can hit function key F4, and it puts a $sign in front of the F and a $sign in front of the 9. What that means is when you copy this formula, do not ever change the F. And when you copy this formula, the $sign in front of the 9 means do not change the 9. Okay, now I could have also, I had F9 here. I could have just come here and said $F $9. I could have typed that normally. And now when I copy the formula down, here, let's use my fill handle again and say format without formats. Now you can see it said 13%, 46%, 17%. I can increase my decimal places 1 there. So now you can see it copied my formulas correctly. So let's double click and look at this formula right here. It changed the F5 that I had on row 5 to F6. I wanted that to change, but it did not change the F9 because my total is always going to be in cell F9. So if we're looking at this formula right here, this is a relative cell reference. If I copy it down to row 7, it's going to change it to F7, and it's going to pick up the year to year, the total for the year of whatchamacallits. If I copy this down to row 8, it's going to grab the total. It's going to change to F8 and get the total for thingamabobs. But my grand total is always in F9. So that is an absolute cell reference. So absolute versus relative cell references doesn't matter if you're going to write every single formula. But if you want to write the formula once and copy it down, you want to make the things that are always fixed in a certain location absolute. And the things that are relative, in other words, I want to be talking about the cell directly to the left of the current cell, F5. And on this row, I want to be talking about F6. And on row 7, I want to be talking about F7, which is the grand total of whatchamacallits. And on row 8, I want to be talking about the grand total of thingamabobs. So this is a relative cell reference, and this is an absolute cell reference. And once again, you can get an absolute cell reference by hitting function key 4 or just putting the $signs in yourself. So if, like right here, if I had F9, I can hit F4 one time and it adds the $signs. But I could have just edited it manually. I could add the $signs. Now, you wouldn't be doing that down here. You do it on your original formula that would start out like this. And then I just hit F4 one time and it puts the $signs on it, or you can just manually type them. So that's relative versus absolute cell references. Got it? I hope that helps when you get into doing the guided project and the Let Me Tries for Chapter 2. Now, the second thing they do in this chapter is they use the payment function to calculate how much a payment's going to be. So let's take a typical situation. I'm going to buy a car for $30,000. And let me get out of here. There we are. I'm going to buy a car for $30,000 at 5% interest for 6 years. I want to know what the payment is. Well, that's a financial function, and that formula for calculating the payment on a car is a well-known formula, and it is built into Excel. So I could either go to formulas right here and look for financial functions and scroll through here until I find PMT, or I can hit the FX right here and say I want to look for payment. and say go, and it wasn't being very helpful. Let's look in financial, and I'm going to look for PMT. So there it is right there, PMT. Double click on that. Now, the payment function needs 3 pieces of information to do its work. If you look right here, it needs the interest rate, the number of periods that you're going to be making that payment. This is the total number of payments, and PV is present value. Well, I don't want to type in the numbers. I don't want to type in 5% right here. Okay, I want to click on the cell. So my interest rate is right here. It is in cell C3. But let me ask you a question. If my interest rate is 5%, am I paying 5% a month or am I paying 5% a year? I'm paying 5% per year. Now, if you want me to loan you $30,000 at 5% per month, I would be glad to do that. That's loan shark. That is criminal interest rates. Go to one of those payday loan places and they'll manage to get your effective interest rate very high based on the fees they charge you. So anyway, this is my, C3, cell C3 is my yearly interest rate. I'm going to be paying monthly, so I have to say divided by 12. Okay, that gets me my monthly interest rate. Now, number of periods. If I click here, it's 6 years, but I'm not making 6 payments. I'm making payments for 6 years. So once again, I have to say times 12. So interest rate has to be divided by 12 to get it to a monthly interest rate, and the number of years you're making a payment has to be multiplied by 12 because you're going to be making monthly payments. Now, present value, that's C2. Now, if I hit OK right here, it's going to say negative $453. Well, why does it say that? Well, because the negative is it's money coming out of my pocket, and people aren't used to seeing it that way. So if I double click on this formula, and I can move my mouse right here in front of the PMT and put a negative sign, and that means negative times a negative is a positive. Now, I could have also said negative C2, negative $30,000, and that will turn it into a positive number. But the way I typically do it is I just come to the beginning here right after the equal sign and put a minus sign. So if I want to buy this car for $30,000 at 5% interest for 6 years, it's going to be $483 a month. All right, so what is the total amount I paid for this $30,000 car? Well, let's run a formula. Equal, that's how much I'm paying a month, times 6 years, times 12. That's the total number of payments, right? So I'm paying $34,786 for the $30,000 car at 5% interest. Now, if it's 8% interest, boy, I'm paying $7,000 of interest. If it's 10% interest, wow, I'm paying $10,000. So that's one of the advantage of writing this formula like this, where you're referencing these 3 cells, is I can play what if. What if it's 4% interest? What if it's 5% interest? What if I decide to buy a $20,000 car over 6 years, but now my payment is $322 a month and I'm paying $23,000. So my total interest, by the way, let's do that formula, equal total paid, that's C7, minus the loan amount. So I'm paying $3,000 in interest for that car. So you can see the payment function is a very common function, and you're going to be doing that in Chapter 2 of Excel. And like I said, the main thing is you have to take the interest rate and divide it by 12. Because remember, C3 is my interest rate. And then I have to take the number of payments I'm making, which is C4, and multiply it by 12 to turn it into monthly payments. Now, let's play a little what if. Say I'm going to buy a house, and the house is at 10% interest, and I'm buying let's just say we can find a $100,000 townhouse. And I'm going to get a year loan. All right, so my loan payment portion for paying for this house, for the $100,000 house at 10% interest paid over 30 years, is $877 a month. Now, what you have to add on to that is your homeowner's insurance might be $1,500 a year, which is going to add $150 a month, and your property taxes might be $3,000 a year for a $100,000 house. So that might be another $300 a month. So you're actually going to be paying more like $1,300 a month altogether if you were to buy this $100,000 house. Now, let's do a what if. I'm going to grab all this right here and copy it and come over here and paste. Let's just do a normal paste. But now let's buy the house over 15 years instead of 30 years. Let's pay it off much faster. Okay. Well, the first thing, let's go back here and look at this house. It's a $100,000 loan. I'm paying for it over 30 years. You notice, because it's over such an extensively long period, I'm paying $215,000 in interest for a $100,000 house. I'm paying $300,000 total because of the length of the loan for that $100,000 house. If I buy that $100,000 house over 15 years instead of 30 years, my payment goes up about $200 a month. So it goes up about 25%. But, going from $900 to $1,075 is not a big jump, because your insurance is still going to be the same and your property tax is still going to be the same. But look at this. I'm paying $193,000 for the house instead of $315,000 for the house. So I'm only paying $93,000 in interest instead of $215,000 in interest. So that's pretty dramatic right there, because I'm saving $122,000 I get to put into my pocket. So now I can buy 2 cars and put them in the driveway of my house, because and look at the effect of interest rate. Say I could get a $100,000 house at 5% interest. Now I'm down to $42,000, and let's change this to 5% interest so we can compare apples to apples. So at 5% interest, I'm paying, on my 30-year loan, I'm paying $93,000 instead of that $200,000. And if I can cut the loan down to 15 years, now I'm only paying $42,000. And look at my payments. My payments have come down dramatically. Let's put this one back to 30 years so we can compare, and I'll do 10% interest. And let me get rid of that formula. So at 10% interest for 30 years, that is $215,000 in interest. If I can cut my interest rate down to 5%, that's only $93,000 in interest. Now, I like the best of both worlds, a low interest rate and a 15-year loan. And you can see here I'm saving a ton of money, versus if I was paying 10% interest over 30 years. That is a huge amount of difference in money. So that's the power of compounded interest. And even if you have a 30-year loan and you can just pay an extra $100 a month, you will pay it off so much faster and save yourself so much money. But that is the payment function. 3 things we have to give the payment function. We have to give it the interest rate, which you divide by 12 to turn into a monthly interest rate. The second thing you give it is the number of payments, which is number of payments times 12, because we pay every month. And then the third thing you give it is the loan amount, the present value, PV. So that is the payment function. You will be doing that in Chapter 2 as well. Now, the book doesn't specifically talk about the future value function, but I like to talk about it, okay? Say I'm going to put $300 a month into an individual retirement account And I'm going to start when I'm 20 years old. So when I'm 65, I want to see what it's worth. And I'm going to say on average I'm going to get 8% a year. So I can use the function future value. So if I do fx right here, and I'll type in fv and go, and I want future value. And future value needs, once again, three pieces of information. It needs the interest rate, the number of payments you're going to make, and how much each payment's going to be. So my interest rate is right here. It is in C4, but once again, I need to divide by 12 because I need a monthly interest rate. The second thing I need is the number of payments. I'm going to be making 45 times 12 because I'm going to have that come out of my paycheck every month. And then the payment amount is going to be $300. So that's the three pieces of information I need to give future value. And that will show me the power of, oh, once again, it came out as a negative. So I'm going to come to the beginning of the formula here and hit my minus sign. So it says if I put in $300 a month at 8% interest every year until I get to retirement age of 65, I will have 1.5, almost $1.6 million. So that's pretty good. You take your Social Security, your other stuff, if you get any pensions, and $1.5 million, I think you could retire pretty well. So once again, let's look what we need for future value. We need, first thing we got to give it is the interest rate. And I've chosen, I'm going to average 8% over 45 years. Some years in the stock market might be 15%. Some might be 1% or negative. But let's say it's going to average 8%. The second thing I have to give it is how many years am I going to be investing? And that's 45 years times 12. And then finally, I'm going to be paying $300 a month. Now, hey, that works out pretty good. Now let's see how much I paid in. So equal, I'm paying $300 a month times 45 years times 12. So the total amount of money I paid in over that 45 years is $162,000, and I turned that into $1.5 million. So how much of that is interest? Equal grand total minus what I paid in. Oops, there we are. $1.4 million in interest. $1,420,000 in interest. That's pretty good, turning $162,000 into almost 1.6 million. Now, we can play what if again here. I'm going to copy this. I'll click here and say paste. What if I only invest my money for 35 years? Okay, instead of starting to save for retirement at 20 years old, I start saving when I am 30 years old. Ooh, that's pretty drastic. So paying $300 a month, 8% interest, but I'm only doing it for 35 years instead of 45 years. Now my total is $688,000. I paid in $126,000. I've made $562,000 in interest. And this is because of the power of cumulative interest. Whatever interest I make in the first year, I get to make interest on that for 44 more years. Whatever interest I make on the second year, I get to make interest on that for 43 years. Let me show you the power of that. Let's go from year 1 and let's go all the way down to year 45. Over. Equal. That's the number of years I'm paying in times 12 times $300 a month. Now I got the right formula. First year I paid in $3,600. Now C3 needs to be absolute. So when I copy it down, year 2 is $7,200. Year 3 is $10,800. In fact, if I double click on this fill handle right here, let's see if I can do it. Nope. All right. If there's nothing below it and I double click on the fill handle, it will copy it all the way down. So I can see after 45 years, I have invested $162,000. So once again, you see the formula right here. This is absolute. This is always in C3. Now the value. All right, so what's the future value going to be? So once again, I'm going to go to the FX here. It remembers I used FV just a little while ago. First thing I got to do is tell it the interest rate. And the interest rate is going to be absolute, is always going to be in C4, and it's going to be divided by 12. Now, the number of payments I'm going to make is going to be year one, so it's going to be B14 times 12 because I'm going to make 12 payments this year. And the payment amount I'm going to make is 300. That's going to be absolute. And I'm going to hit OK. So there we go. And I'm going to double click right here, go to the beginning, and I'm going to put a minus sign in front of future value because a negative times a negative is a positive. So first year, I paid in $3,600. It's worth $3,734. So my interest is not very much, is it? I'll say equal the value minus 3,600. So the first year I made $134 in interest. Big whoop. But if I copy this down, if I copy both of these down, and once again, I'll double click on the fill handle and it will copy it all the way down. So year two, you see I'm using B15, which is 2 times 12 instead of 1 times 12. So I've been investing for 2 years. Once again, my interest rate is still 8% divided by 12, and I'm putting $300 a month. These need to be absolute, so they don't change when I copy it down. So now you see I put in $7,200. It's worth $77. Well, I've got $500. Hey, let's skip ahead to year 10. So in 10 years, I have paid $36,000. It's worth $54,000, and I've made $18,000 in interest. Still not very dramatic, but compounded interest picks up. Let's look at year 20. So year 20, I put in $72,000. My investments are worth $176,000. I've made $100,000 in interest. Hey, we're getting there. Year 30, I've invested $108,000 over the last 30 years. It's worth $447,000. So I've made $339,000 in interest off my $108,000. Now, year 35. If I start investing when I'm 30 years old and I want to start using it when I'm 65, it gets to grow for 35 years. So I invested $126,000. It's worth $688. I made $562. Now look at the interest. At 8% interest, my money grows. I went from $562 to $619. I made $57,000 in interest. Then I made $62,000 in interest. Then I made $70,000. So every year you can put off using it. Once these values get large, 8% of this is a lot of money. So if we look at 35 years versus 45 years, you can see that last 10 years, the value of my investment is just rocketing up. I go from $688,000 to $1,582,000. So I highly recommend that when you get a job that gives you a retirement plan, especially where the company matches money, you max it out. And if you can, put an extra $100 or $200 into an individual retirement account. And for you, if you're young, you want to do it as a Roth IRA, which means you pay taxes on it now and you never have to pay taxes on it again. You can get with a financial advisor. I am not a financial advisor, but I do understand the power of cumulative interest, where you get interest on the interest year after year. So you start out with basically nothing. You just invest, you just put that $300 a month away, and after 45 years, you've got $1.6 million versus 35 years, it's $700,000. So this is how you can make sure you're going to have a good retirement. And you can see just how much it jumps up the last couple of years. Now, you don't do future value in chapter 2, but it's kind of, to me, it's a kissing cousin function to payment. And I just want to show you how future value works for investment purposes. But what you're going to see in chapter 2 is absolute versus relative cell references. And there we go. Oops, let's make that percentage format. And we can see that when we copy this formula down, F9, which is the total for all my products, never changes. So this is an absolute reference. This is a relative reference. That's one thing they talk about in the chapter. The other thing they talk about in the chapter is the payment function. So that's going to do it. I'm going to stop this video right here and do some editing on it and produce it and get it up on YouTube. Thanks a lot. Take care.